Okay, guys, I did this problem in class, but some of you may have been absent, or maybe it was too fast. So if this helps you, good. We talked about factoring. We could multiply the binomial with the trinomial and make one long expression, except that would be going the wrong way, because they want you to tell them what the zeros are. The zeros are what are the x values when y is 0. So you're going to already eliminate 0, -8, and 0, 2, and 0, 8. We want to find the x values. So those are no good. We already know here from here, this is going to be +6. So that's definitely a good one. Then we can get rid of -6. Well, we may actually need it. No, let's back that up, because we may need it for the other, the trinomial, when we factor this. So now we're down to x squared plus 2x minus 8. You want to ask yourself, how can I break up the first term so that when multiplied it equals x squared? Well, that's simple. We're just going to put an x here and an x here. So now we're going to want to break up the last term so that when multiplied, make a -8. And we also have to be careful that it also adds to equal +2. So we're going to look at, let's see, +4 and -2. +4 and -2. So now if we were to go back and FOIL this, x times x is x squared, 4x, -2x, and then -8, and that equals x squared plus 2x minus 8. So that's what we wanted to happen. So moving these factors over here, we have x plus 4 and x minus 2. And what we're asking ourselves are, what are the values of x that create 0? We're finding the zeros of the function. So here we set x plus 4 equal to 0 and solve for x. X would be -4. And over here we have x minus 2. When is that equal to 0? Well, +2. X is equal to +2. So we would look over here back to our selection of factors. We need a 2 and a 0 because x is 2, y is 0. And when x is -4, y is 0. So that's D and A and B. And we don't need -6, 0. So we can cross that one off. So that was the answer to number 1. Okay, so this one is a pain in the tuchus because dealing with irrational and rational numbers is just cumbersome. They're kind of an abstract concept. A rational number is anything that can be written as a ratio. And so because you can take an irrational number and square it, you basically have two of them. It can be written as a ratio. So that's why which expression could represent a rational number when one of them is rational and the other is irrational. So it just doesn't work. Subtracting a irrational is not going to help you at all. So having a negative irrational doesn't change anything. Having a rational and adding it to an irrational doesn't change anything. So that doesn't work. Multiplying a rational times an irrational also doesn't change anything, meaning it's still going to be irrational. So the only real thing is that a perfect square is rational. And so when you have an irrational times itself, you have rational. The answer to your question, a representative of which expression could be a rational number. So b squared can represent a rational number. All right, and then when you come down here, let's take a look. Okay, so it has to be irrational because the whole emphasis here is that it's a quadratic equation. Therefore, you're going to have a coefficient that is multiplied, consider a quadratic equation with integer coefficients with two distinct zeros. So the zeros basically come from, 1 0 is irrational, so the other one has to also be irrational. because we have irrational times irrational to make rational. And we just established that up here. So if you'd say, let's say you'd have x plus an irrational and an x minus an, or yeah, well, we'll say plus an irrational. Go ahead, honey. When you multiply them times each other, you basically make that b squared that we just talked about above. So that's why they set the question up the way they did. Okay, next. Okay, so here we were looking at some systems, and we have, let's see, we have two standard form inequalities, and you want to rewrite these. So we're going to subtract x from the left side, and then subtract x from this side. So you get y is less than or equal to 6 minus x. And so let's see, which one would that be? So we want it to cross, Ben, thank you, buddy. So that's going to be the C or the D. Okay, so that's got an intercept of 6. And it needs to go up and to the left by 1s. So we're looking, C has a slope of 1, and D has a slope of 1 up, 2 over. So already I can tell C is probably going to be my only choice. But let's take a look. So now, is there any other has an intercept of 6? Nope. So now let's see, we have y is 2y is less than or equal to 8 minus x. Again, we have to subtract x from both sides. Then divide everything by 2. So now we get y is less than or equal to 4 minus 1/2 x. Okay, so there's our 1/2 x. So let's see, which one has the y-intercept of 4? That has the y-intercept of 4. So you know what? I did that wrong because I circled the wrong number there. So this is going to actually be D. So let's just erase that. Made a mistake there. So what we're looking at is we have a y-intercept of 6. Do this in red. Oh, thanks, Ben. And then a y-intercept of 4. And so we're saying it is all the y values that are less than. So we've got the blues coming down here. And then we have the reds coming down here. Probably could have done that with different colors. This is red. This is blue. And so what we want to know is where is the reason it's shaded like that is because this shaded area is where the blue and red cross each other. It's the solution to both equations, whereas the area up in here, choose a different color, choose yellow, this only belongs to the first equation there, and then the area down below is only to the second equation, or I guess they're both inequalities. So the green area belongs, Ben, please honey, I'm talking to my students, being a little rude. This bottom area here is the solution to both. So that's the area they're looking for. That's why it's D. Okay, and then one last one. So we have 3 x to the 5th plus 8x to the 3rd. And we want to now subtract 7x squared and minus 6x to the 3rd. So this negative 1, which is implied, has to be distributed to both terms. So we're going to add 7x squared and add 6x to the 3rd. We can combine like terms. So we get 3x to the 5th, 14x to the 3rd, plus 2x squared. Anything over here that looks like that? Yep, that would be letter, 7x to the squared, sorry. And that would be letter C.